All right, guys, welcome. It is 8 o'clock. That means it's time to go ahead and get started. Let's go ahead and get this quiz out of the way. We have a robust turnout this morning, it looks like. All right. Somebody coming? All right. Would one of my humble TAs be able to take care of this? Guys figure it out? There's not that many this morning, so. Somebody's chatting with me. Don't worry, it's nothing weird. Just floating around helping people. All right, let's give it 2 minutes. Do I have them all? Any others out there? I remember. All right. Let's take a look at a synthesis problem here. We went over a couple of these the other day. I want to show you one here that's a little bit tougher. It's a little bit more involved. You can see just how, involved these start to get whenever you're trying to put these sort of fragment pieces together. All right. Let's say you start off with cyclohexanol. And you're trying to make that. Wow, that's kind of scary looking, isn't it? Yeah, so you can go starting off with cyclohexanol and using anything else that you need, try to get to this, okay? I'm gonna walk you through this one a bit, because this one's kind of intimidating at first. One thing a lot of people don't realize is that when they say, okay, starting with cyclohexanol or whatever other compound, you can start off with more than one molecule of that, right? So in this case, a logical course of reasoning, I think, would be to look at this, know that we're going to have two individual fragments here, right? Just like we've seen in the past, both originating from a cyclohexanol. You have to figure out how to get them together, okay? All right, so let's kind of think about this. Plus, we have to get one extra carbon in the middle, right? So reality, this is kind of like three fragments, right? We're trying to figure out how to get these three fragments joined together. And we know one really good way of doing that is through the use of organometallics, right? Well, what are we going to need? What are the basic ingredients for an organometallic reaction? Well, I think one's pretty obvious, right? An organometallic. Yeah. What can organometallics react with? You guys tell me. Be interactive. What are we talking about here? Alkenes, alkynes? No. What are we talking about? What's that? Strong hydride sources are used for hydride reductions. Strong hydride sources would be sort of in the same category as the organometallics themselves, the source of the nucleophile. What have we been reacting these organometallics with in this chapter? What type of compounds? Water's been the follow-up that we've used to protonate oxygens. So it's not going to be water. That's not what I'm targeting. Organolithiums are examples of organometallics.
Alcohols.
Not alcohols. Those are products. You guys are dancing around. You're saying everything but Sarah. Not alkyl halides, although they could react with alkyl halides potentially. What'd you say? Carbonyl compounds, aldehydes, ketones, acid chlorides, esters, that kind of stuff. Yeah, what gets attacked, basically, right? So we're going to need, I think, first here to try to establish a carbonyl compound. We can do that really easily from cyclohexanol. How can we make this into a carbonyl compound? PCC, boom. PCC can oxidize that OH into a carbonyl. Now we've got something going. Now we've got a target. We've got a potential target for an incoming organometallic. Okay, now we just have to figure out what type of organometallic that's going to be. looking at this, let me just give you just a second here to look at this. We're approaching this for 3 fragments, this one, and this one. So since this is the fragment that's directly attached to here, I'm thinking to myself, okay, I need to attach a 1 carbon unit. So I'm thinking maybe a 1 carbon organometallic. What if we did something like this? This is where I really wish I had all the board. I can tell I'm going to run out of space. Because this is a long synthesis. Okay. So we're making progress. That gives us this alcohol and a 1 carbon fragment. Now we don't really need that alcohol, right? It'd be nice if it just went away. We can't get rid of it in 1 step, but what would happen if we added H2SO4? Mm-hmm. Yep. It would make that into a good leaving group, and it would cause the formation of an alkene. So dehydration. Go with me so far? Do we really need that double bond? No. Is there any way we can get rid of the double bond? Think back to an old chapter. Oh, we turned alkenes and alkanes. What's that? P2? PT. Yeah, catalytic hydrogenation. Wow, so all that work basically to replace an OH with a methyl group. But it's helping us build the puzzle. Or, yeah, build the puzzle. All right? Okay. Now, we want now this to be a target. We've got 2 of the fragments lined up. Now we need to connect the 3rd fragment. Again, if we're going to connect fragments, we need 1 of them to be an organometallic, and we need 1 of them to be a carbonyl compound. So what I'm going to do here, and there's actually more than one way to go, more than one strategy you can use here that's correct. What I'm going to do is I'm going to go with the strategy of trying to turn this into a carbonyl. All right? Now ask yourself this. This entire thing is an alkane. You can't do much with alkanes, right? What's the only thing really you can do with alkanes? Can you put alcohol groups on them? Can you put double bonds on them? Can you put halides on them? What's the only thing that you can really do with alkanes? Substitution? Okay, yeah. What kind of substitution? Halogen, yeah. We can stick halogens on. It would be great if we could get a halogen right there, okay? You can't do bromination because bromination is selective. It would want to put it here. So what we would probably do is do a chlorination. We would get a mixture of products. but one of them would be that. Okay. Now, if we want to eventually turn this into a carbonyl, we're going to need an oxygen. We can do a good old SN2 reaction to replace that Cl with an OH. And we're almost there. How do we get that to a carbonyl? 3 magic little letters. PCC. Yeah. Whew. Whew. You see this gets complex fairly quickly. All right. So all that work, and what we've done now is we've gotten 2 of our fragments together, and we've made it ready to accept a 3rd fragment. Okay. I'm about to have to erase most of this, so just want to make sure you guys have it down. Are there any questions about how we've gotten here so far? All right. Can I erase? All right. So we've got this sitting up. Now, we need to get 1 more cyclohexane on this. And we know that let's just use Grignard reagent here just for fun. We know that we can use organometallic reaction. So if we could have a cyclohexane ring in the form of a Grignard reagent, this could attack this carbonyl carbon, and that would link the 3rd fragment together. Just like that. This attacks here, drives a pair of electrons up, and that grabs a proton. And how can we get our final product? We want to convert this into a ketone, right? You can do that in 1 step. PCC. You see how useful PCC is? Great stuff. Are there any questions about how we got that last fragment? Now, we're not quite done yet. The rules said we had to start off with cyclohexanol, right? So we've actually got to show how we got from cyclohexanol to this fragment. Right? So if you remember, to make a Grignard reagent, first we needed an alkyl halide. So you could add some HBr or PBr3. Then add some magnesium in the presence of diethyl ether. And the magnesium kind of squeezes itself between the carbon and the proton. And voila, we have finished the synthesis. So you see, this kind of synthesis is a little different from some of the ones we've done before that have had just a straight pathway. Basically, a lot of times for these, we have to identify the fragments and then sort of do a little separate pathway to make each of the fragments and then show how we join them. Okay? Any questions? All right, I'm gonna do something a little different today. It's Friday. It's fun Friday, right? Nothing's more fun than organic chemistry. Nothing's really more fun than an organic chemistry competition. So here's what we're going to do. I am going to put a synthesis up there, another synthesis problem for you to solve. All right. You can work on this individually. You can work on this with a partner. You can work on this with a small group. The whole class could do it together at one time. Seriously, with like somebody writing on the board and everybody throwing in contributions. The first individual, group, whatever, to get me a correct synthesis pathway gets an extra 3 points on today's quiz. Everybody in that group. Whether it's an individual or whether it's the whole class. Yeah. What's that? Yep. As long as you get it correct. And I'm going to just act as a judge. I'm going to tell you yes or no, this is a correct pathway. You may use your TAs as guides, although they can't tell you the right way to do it. You can sort of ask them for some nudges. So I want to trust your instincts here, putting you on the spot a little bit, to sort of help nudge them in the right direction without giving things away. Yeah, they can write the stuff on the board for you. All right.
Tyler read it. If we're wrong,
for you Zoomers out there, since you're kind of not here, I'll give you the opportunity to do this online. You get something to me by the end of the day. I'll tell you if it's right or not, and then I'll include you. All right, I'm going to sit back now and do nothing and then take credit for teaching. Oh yeah, I guess I should give you a problem. Talk about a rigged contest, right? All right, still starting off with cyclohexanol. Toss a benzene ring in there. Well, Skylar's just there to write stuff down, right? And make suggestions. Yeah. I should do this more often. Let's just sit here and watch you guys.
get extra credit. Again, you
Don't bother asking me how long, how many steps. I have no idea. It's one of those that, takes a while.
Yeah. Yeah.
If you want to sit down, you're more than welcome. I know the painful feeling of awkward standing, waiting for
Tyler.
Yeah.
Can you do H2SO4? Make a alkene or alkene.
Starting with this thing.
Yeah.
Yeah, so that would have a leaving here.
And then NCPDA to make an epoxide. And then a benzene ring with magnesium bromide and H2O.
So starting with the new product.
Yeah.
New.
Or with, yeah, with the new reagent.
So benzene ring.
Yeah, benzene ring. Magnesium bromide. Or it would be attached to the benzene ring. And the second one, or the second reagent has H2O.
Do we have to synthesize the benzene ring to use it? Like we have to make it?
Make a benzene ring?
Yeah.
I mean, benzene's benzene. You could use a benzene ring. Now you'd have to synthesize, if you go this way, you have to synthesize the Grignard reagent from the benzene ring.
So you want to add these two together?
Yeah, and then the second reagent, water, H2O. That should make a cycle with a OH attached to it and that benzene attached to it.
Skylar, I think what she's getting at is she wants to take that epoxide
Add these two
and
together.
have number one, but not like have two steps. First the Grignard and then second water.
So these two. Yep. Yeah.
That works. I think that's a OH, or it should be an OH.
OH, and then-
And then PCC.
Cultivate the Grignard reagent. Somebody said that's a good question. Was that you? It is a good question.
Okay, well, I guess I'll just say, so start with the benzene ring. It's probably wrong.
That's the spirit lesson.
I'm trying. I think you reacted with HBr.
I will go ahead and tell you, you can't react benzene with HBr.
Do BR2 with MPBR3.
We have to start with this, correct? Or can you just start with the benzene?
Oh, yeah, no, you'd start with the benzene. You can't turn cyclohexanol into benzene.
Is this one that would add BR?
Yeah, that's right, except that means just we still have an aromatic ring. Yeah, that's a halogenation. That's one of our EAS reactions. So that, yes, that would put BR on benzene. Okay. All right, well, is there anything else? I'm gonna treat this like Who Wants to Be a Millionaire? You know, is this your final answer?
Yes.
Yeah, that's correct.
Your point.
Meter stick. There you go. See, good things happen in OChem sometimes. All right. Do y'all see how we did this? All right. Yes, Skylar, thank you. You did kill it up there. We appreciate your service. You have the ability to write a lot smaller on here than I do, so you work more efficiently with the board space, which is impressive. All right, y'all see how we got this, the strategy, the synthetic highlight. Are there any questions about how we did that?
Not the most efficient way of doing it.
Is it the most efficient way of doing it? To my knowledge, yeah, it is. It's not the only way you could do it. You could, from this point right over here, actually, excuse me, from over here, actually, you could have just like made this a BR and then done an elimination. Let's see. Actually, I don't know. Let's see. You could have made this a BR. And, oh, excuse me. I'm just going to say yes. Yes, it is. There is another strategy or two, but unless I actually draw them all out, it's hard for me to visualize them. But yeah, to my knowledge, this is the most efficient pathway that you can go for this. Yeah. All right. Cool. Can I erase?
Yeah.
All right. That's the end of chapter 20. Be sure you have lots of practice problems out there. Gave you some sapling, which of course you have to do. And I gave you lots of practice problems in the book, the PDF book. Definitely be working on these. As you can see, they get more and more complex, especially the syntheses. All right. Our next chapter is going to be chapter 21. All right. So what we're going to do in chapter 21 and hopefully 22, we get to it, is we're going to be looking at more and more reactions, specifically of aldehydes and ketones in this chapter, and then chapter 22, carboxylic acid, acids and their derivatives. When's the last day of classes? Do you guys know?
Next week.
Really? I didn't know that. Wow. I was really off with the calendar.
It's like May 7th.
May 7th? Okay. Yeah, my goal is to finish through chapter 22. What I might do is if we start running low on time, I might just start pruning what I think are the most important points out of here to make sure that you guys get ready for your final exam. Your final exam, which is a multiple choice ACS standardized exam this time. Yay! Last day is the 4th? We can work with that. Also, sometime before then, we're going to schedule your third exam, your third regular exam, too. I'll be in touch about that. Starting a new chapter with 3 minutes in the class, probably not the best idea. So I'll give that part of your lives back to you today. Have a good weekend.
I tried to do something.